Hello, everyone, and thank you for joining us for today's Fiber Broadband Association webinar. Today's webinar is titled, What's Replacing Legacy GIS and Fiber Broadband Planning, presented by Enghouse Networks and ESRI. I'm Lisa Rosen, webinar producer at FBA. Before we begin, a few housekeeping items to cover. Please note that all attendees are in listen-only mode. We will have a Q&A session following the presentation. Please ask your questions using the questions tool located on the lower left-hand side of your screen below the video window. We also have several resources available in the related content tool located in the upper right-hand corner of your screen. Also in the upper right corner, you can find reactions if you want to share instant feedback with the presenters. This webinar will also be available on demand on the FBA website under the Events Webinar section. Finally, at the end of the webinar, you will be prompted to complete a brief survey. Please take a moment to respond, as your feedback is valuable and helps us to provide content that is relevant and valuable to you. With that, let's get started. Today, we are pleased to be joined by Tom Carroll, Director of Solutions Engineering at Enghouse Networks, John Lauer, Senior Solution Engineer at ESRI, and Matthew Baber, Geospatial AI Lead at ESRI. Okay, Tom, over to you.
Thank you so much, Lisa. It's really great to be here with the fiber broadband community again. Both Enghouse and ESRI are co-presenting a very interesting topic today. One that talks about next-gen GIS technology, but also how AI will impact that. We'll start with, let me advance so that you can see that. There we go, sorry. So we'll start with a brief overview of the GIS technology and then address specific telecom applications, and followed by a brief demonstration on what that next-gen GIS solution may look like and does look like. But we're going to take that a couple steps further, because the whole idea behind designing a network is to operationalize it. And we'll look at the implications of both the GIS and AI combined on the service assurance nature and that the rest of the network lifecycle. And then we'll finish up with some real world use cases in action. And that kind of brings the whole picture together for today's presentation. We hope you like it. But first, we're going to do a quick poll question, Lisa.
Moment. So I believe that AI can assist us on making better decisions around our network, true or false. So please answer in the poll in the software rather than on the slide, please. Okay, and we have results.
Wow, that's fantastic. 100%. I'm on it. I didn't expect to see 100%. I'd always expect a small percentage, maybe. Not believing that it was applicable to them, but from what I've seen in AI, honestly, it's a little even unnerving, the velocity and ubiquity of AI language models today, free to use, impacting everybody's day-to-day lives in more ways than one. And I don't know, what do you think, Matthew, John?
Yeah, I agree. And I think it's going to be a good topic for us today to show, how that can play into everyone's workflows. I think, seeing that people have confidence that it can help them out. So the rest of our time today will just be a good reinforcement of that.
Agreed. Yeah,
so I want to talk. Go ahead.
No, I was going to say, please take it away.
Yeah, thank you. So I'll talk a little bit about us here at ESRI, and then hand it over to Matt to get a little bit more into our technology. So ESRI has been around for decades, and we've been focusing on helping organizations understand and manage the world through location. So we work with governments, utilities, transportation agencies, defense, natural resources, and of course, telecommunications. And because every one of these industries manages distributed and capital-intensive infrastructure in the real world, we're able to understand everyone's challenges as they pertain to each other. So for telecom providers, that really matters. Your network doesn't live in spreadsheets or diagrams. It lives in streets, and buildings, and poles, conduits, towers. And ArcGIS becomes the system that connects all of that together spatially at enterprise scale. So when you hear ESRI talk about GIS, think about maps and think about a platform that ties all this data together. Now, if we zoom in on telecom specifically, these challenges that you can see will probably sound very familiar. Networks are getting more complex, fiber, wireless, small cells. All at the same time, expectations are rising. Faster builds, better reliability, tighter margins, and real-time visibility into everything that's happening. And so ArcGIS is a platform to approach these challenges. And ArcGIS is being enhanced with AI capabilities to continue helping our users. And AI is only as good as the data that it can reason over. And most network data today can be fragmented, inconsistent, or maybe disconnected from the real world it represents. And so this is where GIS becomes foundational for AI. And ArcGIS provides the spatial context and structure that AI needs to be effective. So being able to connect all of these factors from your network into a coherent view becomes very important. And when that foundation is in place, AI can make a big impact. So I'm going to hand it over to Matt to get a little bit more in detail with this capability.
Thanks, John. So before I switch over to the next slide here, I just want to take a beat and talk about GIS and AI together. When we discussed what we wanted to share with you all today on what the combination of these two technologies looks like, it was, really reminiscent of where we've come all this way, right? John just mentioned that ESRI's been a company since the 60s, and there's been lots of technological innovation since then that ESRI has incorporated into our technology stack to make GIS more accessible and more useful than ever. And we've taken the same approach to AI. When I say that, I mean that when we think about how AI can be used within GIS, it doesn't necessarily mean that a new solution needs new problems. In fact, I wanted to tackle this very old problem of specialized access. And you can extrapolate this to nearly any business system, but I find it to be especially true when we talk about GIS, because it's a technology as well as a science, and there is a lot of specialized understanding that is required in order to operate GIS successfully, to get accurate outcomes. And a lot of this kind of starts with understanding the intent of the question. This could be a request for access. This could be a request for some sort of spatial analytic or geoinformatic. But people typically come to a GIS with a problem, with a question, in search of understanding. And when we think about how this is done today, it's typically a revolving door of when a request for information comes to someone within the GIS department at any organization, it kind of goes through a cycle or a feedback loop where, depending on what the question or the intent or the person asking the question, who they are, there's a lot of things that are considered around, well, what data is required for using this? Is this authoritative or predictive data? Does the answer need to be current today? Or again, is it predictive, looking more forward leaning into the future? Does the answer need to be complete, or will an incomplete answer based on predictive analysis be enough? There's a lot of consideration there. But then ultimately it comes down to, well, okay, what are the pieces that need to come together? What data access, what analysis needs to be performed, what cartographic measures need to be applied in order to make this easily digestible and understandable to the audience. And then that is served out. And there is a huge time delay with this problem. And this is a very old problem, like I said, and it's not even unique to GIS. GIS is just a double whammy of being both a technology and a science. So you're going to have a good understanding of both in order to be a subject matter expert into it. So when we think about how AI can help democratize this currently specialized access, we think of it in this way. Instead of the normal world that we live in, where any request to GIS has to go through this form or request process to a specialized user or group of users that need to understand what data, what analysis, what output is required. What if we could lower that barrier and have a geospatial reasoning agent in the middle that understands what the user is asking, understands what data is required, how to perform a geospatial reason or a analytic in order to get the answer to that question, and then ultimately parse out that information into a way that's desirable to be ingested by the user, to give that information, to give that concise answer to that original question. And AI is actually really adept at doing this, at helping to break down the barriers between what is currently specialized and gate-kept access to data and information and analysis, and allowing for anyone who can ask the question to get their own answer, and really expedite the process of these very common where questions that often bog down today's GIS departments. And to kind of give a more clear example of what that looks like, we're going to play this brief video, and I'm just going to talk over it as it plays. Is that playing for everyone?
Yep, you're good, Matt.
Okay, great. Can't see it on my screen. So this is just an example of, did something happen?
Yeah, hold on.
Okay. Apologize, everyone. The hardest part of any demonstration is just sharing your screen.
Yeah. Is it playing now? I don't see it.
We need to let Lisa play it.
Lisa, go ahead.
Now you go ahead, Matt.
Okay, great. And this is why we chose to use a video, to try to break down the audio-visual barriers, just like how AI is trying to break down the barriers of specialized access. So in this example, it's a very classic example. Building a fiber route extension to a location with multiple routes kind of being assessed for their validity. And there's a number of variables that kind of go into proposing these routes, but ultimately a decision needs to be made, right? Well, a GIS houses all this information, houses all the data, the analysis, but now it also houses the capability to have a real-time conversation for an assessment. In this example, what we're looking at is these 3 routes and asking using normalized language, just how long are these routes? And based on that length, what would the average cost to extend each route? What are the customers around these routes that we could possibly add service to that are within a certain buffer? What data do I need to even answer these questions? Well, as I'm having this conversation with this geospatial agent that now lives within the GIS, it is gathering this, what data that I need, what analysis that I need to do, in this case, a buffer analysis around the routes, in order to answer these questions all in real time. And the point of all this is I don't have to be a geospatial specialist in order to get these answers. I just have to be able to ask the questions. And then the geospatial agent understands, oh, he's asking about the Longwood fiber routes. I'm going to find that data. I'm going to put it in the map. They're asking how long each one is. Okay, well, I know how to look at the attribute table, find that length field, understand the metadata tells me it's in meters. So when I give them a response, it's not going to be 1,000 unspecified units. It's going to be 1,000 meters. Then asking more complex questions. Well, what customers that we currently aren't servicing around this area could we service based on each of these 3 proposed routes? Okay, well, I need a new data layer for that, so let me go out and find it, and then bring all this in. And then you can challenge this agent to say, hey, show me the steps that you used in order to answer this. And then after you kind of have this conversation and you get the responses, and based on whatever other kind of contextual conversation attributes there are. So if I'm asking, hey, what does Route 3 look like, and show me the customers around it, it understands, given the context of that, to keep the conversation flowing, that these are the variables that are at play, and these are what the answers to your question are going to be dependent upon that route. The same way you would have a conversation with someone from a GIS team today, but it's happening instantaneously, and it can happen at scale where you can have multiple people asking questions of the same agent at the same time, involving different scenarios, different data, different analyses. And these very common where questions that are currently bogging down almost every single customer that I work with are now self-serviceable. And then the GIS department is then freed up in order to create more authoritative data, keeping it current, increasing their stewardship, their governance, and their policies, building out new geospatial analytics to power future agents for more of these question and answering prompting. So going into this final slide here before I pass things back to John. Of what this is actually going to do for utilities today, and for telecommunication companies today, is geospatial AI kind of moving to be that front line between people who have requests of the GIS department and the actual GIS department, allowing them to specialize in their domain of expertise, to continue to practice that GIS that they do today without having to constantly be interrupted with, hey, where's the data for this? Or, hey, what's around this area? Or, we have these 3 fiber routes. I need you to create all of these different geoinformatics based on each route, depending on some quick questions that I have, and then constant revisionings of this over time where, okay, you asked how long this route is or what customers are around it, and I sent you the information, and then you decided, oh, well, I also want to know these 3 other routes. Okay, well, now I have to do another stage of analysis. A lot of these really time-consuming specialized access problems become more democratized, and you see real value in just the time savings, as well as allowing people to kind of create their own geographic interfaces and get access to that specialized information. So with that, I'm going to hand things back to my colleague John to go into some questions.
Thank you, Matt. And we're going to initiate another poll question specifically around how does your organization currently plan fiber networks? So Lisa, if you go ahead and initiate that poll question. Thank you. Give a few seconds here to let everyone participate. Okay, Lisa, if you wouldn't mind showing the results. Okay, we're looking at a decent bit of some GIS integration, pretty similar in advanced GIS workflows, and then I guess pretty even stretch across the 3 of not involved in planning as well. So looking at the question or the answer around fully automated or AI assistant being at 0%, I think we can understand people are still in the exploratory phase today or still trying to get a grasp on just how AI can help. So we appreciate all those answers. And I think, Matt showed ways that you can start thinking about AI from this perspective. But at ESRI and with our partners, like Tom is going to talk about here in a moment, we understand that customers are on all different stages of maturity, so to speak, when organizing and planning fiber networks. So being able to just identify what your needs are is where we really like to have those conversations, and then talk about capabilities and solutions for you all as you push forward in advancing your networks. So Tom, with that, I will hand it over to you.
I believe you're on mute.
Sorry about that. So we started off by looking at the GIS-based planning and design phase of the network lifecycle and using natural language AI models. So obviously the idea behind planning and design is to operationalize a network. So instead of just considering that as a standalone topic or concept, we want to take that through the rest of the network lifecycle. And the planning and design, that produces some very important artifacts for the business case, right? It includes site survey information, bill of materials, cost information, of course, and construction ready diagrams, right? And all those impact the network rollout, how it happens, where it happens. And it's that information is critical to the operations team as well. So what we're going to do is we're going to look at how not only GIS, but how AI also are applicable to the rest of the network lifecycle that we see. And especially we're going to focus in on the service assurance aspect of that. So now looking at it from a visual perspective, and I like to look at this diagram from the bottom up because its foundation is location-based data. It is a GIS engineered solution that it's not at that stage, at that foundation, it's not just about the network, it's about everything else as well. It's about network topology, it's about geography, civil works. You have, electric utilities using it as well. You have buildings, it's where the communities are, it's where the customers are. So with that context, then the service assurance layers, the operational layers are based on top of that, and now can analyze and determine location of fault information, performance degradation, where those hotspots are, to provide that context in terms of how are we doing today to the executive or the business itself. So the business looks at a different perspective, and its perspective is really how is the business running today? How's our customer experience? What are our service level agreements? Are they within range? Or we have some that are out of range? What's that going to cost us in terms of trying to repair that service or network? And are we positioned correctly for expanding this same network? So if you look at it, it's really a foundational layer of data, location data, and everybody has a different perspective of that data. So we're going to explore that a little bit, and we're going to dive into that service assurance layer as we go forward. But first, we have another poll. Lisa?
Okay, what is your top priority for improving fiber network planning? Reduce deployment cost, accelerate rollout speed, improve design accuracy, better asset visibility, or enable automation AI? Give everyone a few moments to answer that.
Okay. Well, that is actually very interesting as well. So a majority of the people looking at improving design accuracy. Absolutely. And if you're not using a GIS-based solution today, then that would probably be the case. John, what do you think?
Yeah, it's interesting to see these. I think, a lot of these can be rolled into the power and the use of GIS. So just understanding these challenges from our side is helpful to see. And I continue to encourage people how GIS can start to fulfill some of these. So thanks for sharing.
Yeah, thank you. Okay, so moving on to just some details on how that manifests itself in service assurance, right? So, and I'll call it GIS-based service assurance, and it's whether the network is your business. In other words, that's your money-making, your commercial reason for having the network, or whether it just enables your business, a municipality or DoD or an enterprise of any kind. It's critically important to understand the where of the network. Where are your customers, the communities you serve, the first responders, all these consumers of your service. So it's critically important that you understand the where, and especially where are your field teams in relation to your network, so that you can have somebody who's close to an issue respond quicker than driving somebody miles and hours away to get there. So the operational part of that really is what we call service assurance, is the managing and monitoring of the network as built. So it's specifically, it's fault performance data, configuration management data, trouble and workflow data. And that's, a network operations team would be looking at a real-time end-to-end platform that shows them where the alarms are and in relation to the geography. Almost every service assurance platform has the concept of location, a map, a logical diagram, but then the logical diagram itself is subtitled with location, so that you can see where you need to go to bring back and restore services. Geospatial information is just really critical to pinpoint, and especially when you're talking fiber cuts and analyzing, OTDR traces or network traces that's showing you where a cut might be in terms of miles of glass versus actual geospatial or location-based data. So that's a critical intersection of those two types of data sets. I don't think there's any more important location-based information than 911, right? Of calling 911 and they having the concept of knowing exactly where that call came from, even if it's on a mobile phone or in whether it's from a computer like I'm talking today. It's critically important that they know where to go, where that call came from. And so it's also for outbound communications, for emergency and disaster recovery, of sending out broadcasts to a specific area, like within a single cell tower, to let everybody know in that area that there is a disaster, there's an emergency, they either need to avoid or to get out of the way or to go someplace else. It's critically, location obviously in that context is critically important. And that enabling first responders with that type of information is the real key to saving lives. Okay, so now we've talked about what that service assurance platform might look like, and also a GIS planning and design platform might look like. But this is what it looks like. And it's really a perspective, again, like this information you talk about, you have like geospatial engineers, people GIS trained who understand and have developed the core construct of this information, sharing that information to an operations team. This is a web-based application that both ESRI and Enghouse have partnered with to produce, that's 100% web-based. And the concept behind this was to make it simple, intuitive, easy to use for somebody who's not a GIS expert. They're just taking advantage of all the engineering that went into that data set, but being able to point and click, making it simple, but also having those same powerful features and functions that you would expect somebody even in operations or in the field team to have access to, but also to provide things like red lines, to provide comments and even additional context around that individual enclosure or site. So it's also an intersection of the fault and performance data, so that the alarms now, through standard APIs, appear on the map in the location where they've been identified. This can be leveraged by a field team, and they can actually see by fixing the solution that the alarm in the real-time system would actually go green, that it would remove the alarm, and they could confirm that the service was restored themselves without having to go back through an entire feedback loop. So this is obviously just the next generation of it's not just about network planning and design, it's about how that network planning and design is used by others in different perspectives. Okay. So now, and I want to take that foundation and move to the next step of AI-infused service assurance. And this is something we've been working with for quite some time. It's something that you're either doing today and you've gone from experimentation to operations. That's kind of where most of service providers are. They've done some experimentation around this, but it's really what I like to call conversational creation. It's conversational analytics using a natural language model to be able to go from a concept to creation in a very short period of time, and then be able to test and validate that in the same conversational nature. It's very important also, and you look at the other aspects of AI and service assurance, fault prediction is something that we've proven with service providers to be quite accurate, using historical data to analyze and predict when the next alarm is going to occur and where it's going to occur based on history and trouble ticket information. It's also the means by which autonomous networks can be envisioned. We don't know many people who have gone all the way to fully implementing autonomy. That's actually one that requires a bit of trust and testing to make sure that the response doesn't create a bigger outage than the one that you currently have. So there's the concept of semi-automatic, where the analysis of the data says, here's what's happened, here's your historical best practice on how to resolve this. Would you like me to reset this interface? And then allow an operator to agree and push yes, and then that automation to occur. Probably the easiest, the lowest hanging fruit right now is around trouble orchestration, providing information to people maybe who are less experienced, that they can use the context of history of here's how we solve problems. Here are, again, the best practices to guide somebody through not only the alarm notifications, but what are some of the actions they may want to take before they go and make a change in the network, but also a big time savings in documentation. It's really a big time saver for everybody. I don't know, including myself, documenting what happens in meetings and documenting what happens, for proposals. AI has proven that it's a huge time saver in that regard, especially for experienced people when you want them working on the next problem, not sitting there and handwriting or typing in what the solution was, and using AI to help fill in those gaps for those experienced people. And then lastly, this is it's the TM Forum's Catalyst project, and the Catalyst project is sponsored by this organization that specializes in telecommunications. And what's required is that you have to have two service providers. This is, in this case, is DO from Dubai and Sri Lanka Telecom, also with the Florida Institute of Technology, where we did a machine learning and alarm prediction catalyst project, which included other vendors that would do things downstream to close the loop and make provisioning changes. So this is fault data, performance data, trouble management data, even weather data. Millions and millions and millions of records were analyzed by machine learning and AI models to predict when the next alarm would come in, and then feed in additional months of information. And the accuracy was well over 90% of predicting what the next alarm was going to be. And then once they got past that phase, we said, when you do predict that, when it does happen, here's the automated action that we want you to take to re-provision that interface, because it's based on the best practices for that specific alarm that will restore that service. And so it ended up being a full closed loop. And from that, we built on top of that to add in natural voice to text, to be able to speak and ask for, what are the most common areas that we could automate with this same response? What other alarms would benefit from that same thing, and have the analytics, conversational analytics be provided back to you doing that same thing. And so the latest one we have done last year was around that, what I'll call virtual assistant model I just described, where when an alarm comes in, it presents the information to an operator. If it's a less experienced one, it guides them down the path. If it's a more experienced one, it reminds them, here's the procedure. Do you want to continue? And here's the documented steps that you took. Are these okay? Go ahead and submit. This year, we're looking at a more location-based one that would do auto provisioning based on location of severe impact events like a typhoon, which did happen in Sri Lanka, and they are, again, one of our code presenters for the solution. We have this available on our website, but we'd be glad to share this with you. The details, the different actions and responses that we've been able to produce. So we're really excited about this next phase of where we're going and how this all ties together. So with that, we're going to move towards the conclusion. And so I'll start off by saying, you know, the GIS is definitely the foundation. It's an incredibly powerful location source, not just for network, but for all those other areas, including geography, topology, population density, demographics, your civil works, all that comes together. That can only benefit you in the network layer and the service assurance layers and the upper layers of your operations. And then service assurance, which is really, I believe, a foundational aspect for implementing AI, simply because it's this continuous monitoring and data collection across your network. It filters out the data you don't want. It includes and adds context to the information you do want. It helps cleanse the data that you're using for AI, for upstream processes like that. So it's good data hygiene to have a system like that in place as the foundation of which you can build your agentic AI solutions and move forward. And then from an AI perspective, we'll ask Matthew and ESRI to go ahead.
Yeah, absolutely. So, you know, probably the number one contender for AI adoptance that I run into is around this idea of, I believe I mentioned this already, a solution looking for a problem. You know, we've all experienced AI in some shape or form in our lives, or perhaps professionally, and you know, we understand the value and we understand what it can do. But it seems like when we actually comes time to like apply it to a problem, we're looking for that problem. Where can I throw AI at something? Instead of, you know, revisiting these things that have been problems and are problems today and thinking about them differently, we might have solutions for a lot of things today that could be made better by the application of AI. So when I think about how to leverage AI, I don't think about, well, what's the next big problem we're going to have and how will AI help us tackle it? It's, what are the problems that we're having today? And you know, maybe it's worth revisiting these problems, even ones that we have established solutions for, and just think about it differently and think about where can AI add efficiency or where can AI add value to help organizations, you know, tackle things a little bit differently, a little bit better than they have before. And in this way, you kind of build a solid use case around problem solving for AI, and you'll be more successful, I believe, with that approach than just saying, okay, I'm going to wait for the right problem to apply AI to, or I'm going to wait for something new to apply AI to. Just be thinking about what am I doing today, and in what ways could it already begin adding value outside of, you know, things that I have traditionally only sort of looked at AI for. Just thinking about a problem first, and then AI is one of the potential solutions that you can apply to it.
Excellent. Thank you so much. And Lisa, with that, I think we are ready for questions and answers.
Absolutely. So we have a few questions that you all entered during the registration process, and we will start with those. And then we'll go to live questions. So please go ahead and enter any questions you have in that Q&A widget I told you about on the console. So we'll start with this one. Can the natural language GIS or automation hooks you're discussing interpret field notes, red lines, or CSV exports to automatically update geographical areas or individual locations rather than having a GIS tech manually move points and edit attributes?
Okay, I'll take that one. And so from an application perspective and looking at the workflow of somebody in the field making changes maybe based on an engineering design, and they walking through that the implementation, the as-built, is different from what was engineered. Now, absolutely, that could help with that, but a lot of what we're trying to do as a first step is put the same system of record in the hand of the field technician, the people who are making the changes, who are doing the splices, who are installing the fiber. Those as built and those red lines can be put directly into the system of record at that component in digital format with a laptop. The web-based solution is very compatible to that type of workflow. The AI component as being able to, one, do image recognition, but to also do validation testing of, does that change the way you implemented it work, and does it follow our engineering rules, so that the GIS experts who are engineering the network and the field technicians who are implementing that there's not some sort of violation in the way that's being done. And AI could definitely be that guidance of saying the way that it was input, that this needs to change to follow our best practices, our engineering guidelines, because there should always be an approval phase that occurs within the engineering team to say, okay, wait a minute, you made a change, but that has a conflict with what we're doing next. Maybe we're looking just at what we're doing right now. So it can definitely improve and make sure that all those gaps, or if there's anything that must be input, the AI can identify those and prompt for that information. But I think in the future, what you'll see is that a very similar one where that conversation will be, hey, based on the engineering design and the site survey, I want to make these changes. Can I do that? And it would absolutely go through the same demonstration that we showed today and provide guidance on how that should be done to not violate any of the engineering rules or best practices.
Great.
Okay.
Can you expand on how to use data sets from various funding agencies about eligibility areas to support exploration of funding for fiber build out?
I can take that one too as well. So because both Enghouse and ESRI are partners, and ESRI is the default standard for the U.S. government in terms of demographics, population data, served and unserved areas. They have that common data set, so that's a layer of information that they already have based on location, right? And so being able to design a network on top of that data to show, and that it's basically you're building the business case to receive funding that shows how many areas you are serving, especially the underserved areas or unserved. But also those anchor institutions, libraries and schools and things like that, where you get the biggest bang for the buck with multi-dwelling units that you can show the business case provides the most value to the U.S. government in their funding.
Okay, thank you. Okay. How well does AI work with messy, unclean data that comes from decades of various database to CAD to GIS conversions?
Matthew, you want to take that one?
Yeah, I'll take that one. Okay. So AI is not magic. The sort of age-old adage, garbage in, garbage out, still applies in the world of AI. If it's not something, if the data is not in a quality that a human could use it for whatever task you're trying to accomplish with it, then AI is not going to either. So I would do an assessment of the data and figure out what you need as a data readiness assessment in order to power whatever AI application and tooling that you are seeking to utilize. And then kind of with that gap analysis, understand what steps you need to do and what in what order to bring your data to a place of readiness for that application. I will say, though, that there are, ironically, a lot of really good AI data cleanup tools that help identify common issues with geospatial data that can really put you in a place of kind of being able to more be expedient with your ability to clean up a lot of your data. These toolings are really looking for things like gaps in your metadata or geospatial inconsistencies, like maybe you have a lot of stacked points in an area that shouldn't be stacked, and these kind of things that AI is really good at identifying and supplying potential solutions for. But yeah, it's not going to be able to do if your data is just in a completely unusable state, then it's not going to be able to provide you anything outside of what a human could do. I'd probably really encourage you to think of it that way. Is this stuff is not, it's just technology, it's just science. It's not going to be able to magically fix everything. It needs a state of readiness in order to give you consistent and accurate answers.
Thank you. What about privacy when you share with AI?
I'll take this one as well. Yeah, so there's a lot to consider with privacy and AI. I would say know your vendors, know whose AI you're using and what the terms of service are. If you're using that AI completely disconnected, or if there is a SaaS element to it, whereas if you share data with the AI, is it going somewhere? And if so, where? And what is it being used for? Is the AI not just using your data, is it also training on you? So there's a lot of considerations when we're talking about just generic AI and what privacy you can expect from it. I'd say a good rule of thumb is to treat every piece of AI technology that you don't have a firm understanding of the terms of use for as if you were talking to someone external to your organization. Would you share the data that you're about to put into this AI tool with someone who's external to your organization? Would you trust someone with giving you insight into, if you're using a piece of AI technology to help you draft an email or anything? Would you trust them to give you that insight and not have an angle that they're trying to play? Or what would they do with the context of that email or that draft of information that you're putting together? So that's kind of how I think about AI that I'm not completely familiar with, is would I give this to someone who I just met, or someone who I don't know, or someone who I can't trust? And if the answer is no, then you probably shouldn't use that tool until you understand the terms of use around it.
Great.
Yeah, and I would add to that just real quick that even here at Enghouse, so there's two aspects. One is we have an internal AI model that's approved by the company, that's private to our organization, and only that can we use if we're uploading, let's say, company confidential information or things that are private to the company. And then if it's anything else, you're just doing competitive intelligence, or you're looking for some other AI benefit, then that's okay to use a public language model. So we have in most of these companies that we're talking to today, you probably have something similar, where if you're going to use it, you better make sure that you're not putting company private information into the public language AI model.
Yeah, that's a great point. And a lot of vendors, ESRI included, we have on our trust site, we have what we call transparency cards around all AI technology that ESRI puts into its products. And so if you opt into using it, these transparency cards will tell you exactly, based on the tool or based on the assistant or the agent, exactly what pieces of AI technology are being used. what they are allowed to do, what data are they allowed access to if you give them data, what processing are they allowed access to if you give them access to processing. So I would just make sure that you adhere to your internal AI governance and policies around that, and make sure that you hold your vendors accountable, and that you can understand how their AI tools are being used, even within your own organization.
Yeah, good point.
Great. How far are we away from creating a polygon service area and origin point and having the AI go from pole to pole, drawing the backbone, laterals, drops, etc.? Is that an eventual end game?
I can make an initial comment on that. As far as how far away we are, I can't speak to that, but I'd say an eventual end game, yeah, totally a possibility. And I think we're kind of walking the line of AI versus just GIS automation. So understanding, the rules behind how you want your network to be built can be just a simple automated process of some geoprocessing tools or other spatial analyses versus having an AI engine be able to connect those points together. So short answer, yes, as automated as we can get, that's great. But being able to still have engineers' eyes on it will still always be ideal in my mind.
Great. What out-of-the-box AI models are available from ESRI to work with pole and fiber data?
Yeah, I'll take that one. So all of our out-of-the-box tools are on our webpage as a part of our Living Atlas content. So if you just Google ESRI Living Atlas, you'll find our repository for all of the publicly available spatial data, as well as deep learning tools, these AI tools that we put out that are all pre-trained. And there you can kind of search for poles or fiber, whatever you're searching for, and you'll find all of the tools that are pre-trained there. I'll say that we are constantly updating our Living Atlas and adding new tools all the time. So if you don't find something that you're looking for today, check back in a month or so and see if it's there. Also, all of those pre-trained tools are built off of the same toolkits. So if there isn't something and you don't want to wait, you can just build your own. And then if you build something that you feel like sharing, you'd let ESRI know, and we'll authenticate it, and potentially we could put it up on the Living Atlas as something that you've provided for the community.
Great. Looks like we have time for one last question. How can AI be efficiently used in GIS day-to-day work?
Yeah, sure, I'll take that one. So ESRI's strategy around AI adoption comes from a place of just, we're ESRI, we are a geospatial company. We are not an AI company. So the way that we think about AI and adding it into the platform is, in what ways will it enable geospatial? So across our tools, our application, and enterprises, these are the three areas for AI adoption that ESRI has considered. So we have these intelligent tools like I just discussed on the Living Atlas, but we also have intelligent applications. So these are assistant-enabled apps that have an AI assistant in them. These are productivity tools. And then we have agents for automation and communication to other business systems and integration with other business systems. So when we think about in what ways can AI enhance GIS, it's across the stack. It's across every piece of the GIS, from running a tool to working in an application to integrating and automating the GIS with other business systems. Across that entire space has AI technologies that ESRI's made available for our customers to use to enhance that experience in some shape or form. So certainly too much to dig into now, but do understand that there's very few places within our platform today that cannot in some way be enhanced with AI.
Great.
Yeah, I would agree with Enghouse as well. We look at that in terms of specialized language models. It's not infinite input, infinite output, but you're trying to achieve a specific goal, an automation or something that makes the job easier, faster, and makes your people's life easier. And that's really our goal, our function, is to put that in the hands of our customers to make the technology easier to assimilate, easier to operate, easier to maintain.
Perfect. Thank you so much. So this is a quick reminder for you all. Please to join us at Fiber Connect in May. The information is on your webinar console. And here's a QR code you can scan if you would like to volunteer. And then to learn about upcoming FBA webinars, please scan this QR code on your screen or navigate to the events section of the FBA website. We hope everyone will join us for our Fiber for Breakfast webinar series featuring FBA President and CEO Gary Bolton. These are live every Wednesday at 10 a.m. Eastern, and past episodes are available on YouTube and SoundCloud. Thank you very much to our presenters, and thank you all for joining today's presentation. Have a great day, everyone.
Thank you, Lisa. Thank you.